Hey guys, Chili here. Welcome back to Project Twin. Today we are going to add a projectile attack for our Chili character, and we're going to get some first-hand experiences with the fun of vector instability. Alright, we got the Chili, we got the poo, we got the collision. Now it's time for some bullets. Remember, this is ostensibly supposed to be a twin stick shooter. We're going to probably need some bullets in there at some point. I haven't actually, committed to this being definitely, bullet-based twin stick shooter. It could have melee elements or, a mix of the two. I don't know yet. But for right now, we want bullets. So, added a bunch of stuff. Obviously, what you're going to want to look at here is bullet.h. That's going to be where the big action is at. And it's a very simple class, much simpler than the other character classes. All you really have is a way to get the hitbox, to get the position, you update that guy. So when you create the bullet, you create it with a direction and a position, and it will move in that direction based on its speed. And there you go. That's pretty much it. I mean, I also added the fireball.bmp. That's the graphic for the fireball, obviously, and it's just a fireball from Super Mario Brothers, if you want to know. chiliutil.h. What did I do here? All right, so I added a little function here to remove an element from a vector based on its index, and it just does a standard swap and pop. So if we want to remove element 5, it will swap 5 with the element at the end of the vector, and then the one that we remove is at the back, and we can just pop it off. And that's a lot easier than calling erase, because if we erase, we have to basically copy all the elements after element 5 up by 1 to fill in that empty space that was vacated by 5. So the difference between remove element and erase is erase maintains the order of elements in the container. Remove element does not maintain the order, but remove element is a lot faster. And we don't care about the order in the bullet container, so we were using remove. Now, what did I change in poo? Because I don't really know what should have changed. I just got rid of an extra pragma once. Okay, simple enough. In vec2, I added comparison to compare two vectors, equals and not equals. So I guess that's being used somewhere. Mouse.h, okay, so get position now returns a v2. That's a little more convenient, I suppose. Game.h has a vector of bullets, and it includes bullet. And game.cpp, here's where all the magic is going to happen, I suppose. So what we're doing here is, well, I mean, the keyboard is empty, so we switched over to processing mouse messages, and we just if there is any mouse messages to process, read them out. We process left button presses on the mouse, and we use the position of the mouse at the time that the button was pressed to determine the direction of firing, and we fire off a bullet, which means we create a bullet and we put it in the vector. So that should be pretty straightforward. And here in the update, is this update? Update model, yeah. Here we are updating all of the bullets based on DT. That is how they move across the screen. And here we're going to want to test every bullet against every poo to see if it is any poos have hit any bullets, and if so, we want to do something about it. At the very least, we want to get rid of that bullet, probably. Probably also want to do damage to the poo, but that's going to be later. So, since we're already looping through every poo, all we do here is we get the hitbox for the current poo, and here we do the same check against Chili as usual to see if we damage Chili. And then here, we loop through all the bullets, and if we find a bullet that's overlapping with the poo, we remove that bullet, we activate the damage effect on the poo, and skip incrementing index. Okay, yeah. This is a little complicated here, but basically, so let's say I'm iterating through this container of bullets here. I find one that needs to be removed. What do I do? Well, I'm going to swap it with the one at the end. So D and I get swapped. I goes in here, D goes in here, get rid of that. Now with a normal for loop, what I would do is after I would do this operation, I would increment, and then I would proceed to test this one. But that's not good here, right? Because we just did this swap. So this element here is now an untested element. So that means that if we do remove, if we do a swap and a pop, we don't want to increment, because now the thing that's currently being indexed is something that hasn't been processed yet. So we want to again process this same index. And that's what we're doing here. If there's a collision, we remove based on index, and we activate effect, and then we continue without incrementing. Otherwise, we increment. So this increment here is not in the for loop as you would normally see. And you might be saying, Chili, why using a for loop? Why not use a range-based for loop to loop through the bullets? And the reason is we need the index, because the remove element function takes an index. And there you go. And down here in the draw, all we do is we range-based for, and we draw the bullets, and I'm also drawing the hitbox of the bullets just for visualization's sake. And if we build and run that, we get big old errors. So what's the problem? Well, we got some template bullshits in here, and the favorite kind of errors, attempting to reference a deleted function in bullet. So, well, what is bullet then? Well, we haven't deleted the assignment in bullet. We have surface, we've got animation. So if we look into animation, we can see that animation has a reference to a sprite. And that's a problem because you cannot assign to a reference. You can't reseat a reference. So if your class has a reference, it is going to have a deleted assignment operator. And if you have a class that has a deleted assignment operator, your assignment operator will also be deleted. So what's the solution? Well, what we can do is in animation, we can change this reference into a pointer. Pointers can be retargeted, so then the assignment operator will work fine. And here in animation.cpp, we change, we're passing in a sprite by reference. Here we get the address of that sprite, and that is how we set up our sprite pointer. And here when we're drawing, obviously we're gonna have to dereference that. And this will build and run, but another thing it'll do is it'll crash. So now we have the fun problem of trying to figure out why this bullshit is crashing. It's probably a problem here with sprite drawing, but that doesn't mean that that's the root cause. So in order to figure out why we got crashes, first thing I did was I added debug time step. And this is important when you're debugging. If you use a frame timer while you're debugging, when you break, the timer is still running. So then when you resume, it's going to think that you had a time step of, like, let's say 5 seconds. It's going to try to process 5 seconds of your simulation, and you're gonna have a bad time. So what you want to do is you want to give every frame a fixed time step when you're in debugging. So that way, when you pause the game, you're not going to have a huge long frame when you resume. So I did that, and then I fixed the problem. And the problem, so when we created a bullet, we fired it, that was fine. Then when we created another bullet, the thing crashed. And the reason why is because it was doing a shallow copy of the bullet, and that's no good for one reason. So our bullet contains a surface and it contains an animation, and the animation contains a pointer to the surface that's in the bullet. Now when we do a copy of the bullet, for example, when the vector is resized and it needs to reallocate, we're going to get a deep copy of the surface, because surface implements a deep copy assignment operator, but we're going to get a shallow copy of the animation. And what the shallow copy of the animation means is that P surface here, the pointer is just going to be copied. So this pointer is also going to point to this memory from the old bullet. So if we have a reallocation of our vector, it is going to create a new block, is going to copy over all of the bullets, and then it is going to destroy all of the bullets in the old smaller block, meaning that our shallow copied animation is now pointing to a surface that does no longer exist, and we're going to have a bad time when we try to draw that surface. And how I solved this problem was I implemented the copy constructor and the copy assignment for bullet, and I did it in such a way that it does not use the copy from the animation. So the copy constructor, instead of copying animation, it just constructs a new animation using the surface in the current bullet object. And for copy assignment, all it does is it ignores the animation. It doesn't change it at all. Because the animation, when you copy a bullet over, you're really only copying the position and the velocity. The surface will stay the same, the animation stays the same for all bullets. So what I do is I just ignore those for copy assignment. And for copy construction, I construct a new animation rather than trying to copy one. So I did that, and then I realized that the bullet wasn't animating. So I went into bullet.h, and in the update, I call bullet animation.update with DT, which is what I should have been doing, but I forgot to do it. And in game.cpp, I removed the drawing of the rectangle. And here you can see now we got our bullets, and the bullets are hitting the poos, and the poos they're flashing with the damage effect. So everything is looking good so far. But yeah, this situation where whenever we have an animation, we've got to worry about the thing that uses the animation being copied, this is actually just terrible. And later on, we're gonna have a much better handling of this. We won't have to worry about creating special copy members to tiptoe around this problem. But for right now, we're just gonna deal with it, and later on, we'll get some better tech, trust me. The major takeaway from today's episode is we got to be careful when we deal with references and pointers to things that are stored raw in a vector. Luckily, this isn't going to be much of a problem for us later on, because we're going to be storing more and more of our stuff on the heap. Like, we're going to be storing our surfaces on the heap because we want to share them between entities. And eventually, we're going to be storing our entities on the heap because we want to leverage polymorphism. But that's a story for another day. Hope you liked the video. If you did, please click the like button. It helps a lot. And I will see you soon with some more Project Twin.